Hello, this video is for textbook chapter 2, lesson 5, solving for a variable. The objective of this lesson is solve a formula for a given variable, and also we have the objective of solve an equation in two or more variables for one of the variables. Our vocabulary for this lesson is formula and literal equation. So who uses this? Athletes can rearrange the distance formula to calculate their average speed. Many wheelchair athletes compete in marathons, which cover about 26.2 miles. Using the time, represented with the variable t, it took to complete a race, and the distance, represented by the variable d, and the formula of d equals r times t, racers can find their average speed, which is represented by the variable r. A formula is an equation that states a rule for a relationship among quantities. In the formula d equals rt, d is isolated. We see that d is all by itself on one side of the equation, and it equals the product of r and t. You can rearrange a formula to isolate any variable by using inverse operations. This is called solving for a variable. So in our table here, we have solving for a variable. Step 1 is to first locate the variable you are asked to solve for in the equation. Step 2 is to identify the operations on this variable and the order in which they are applied. And then 3 would be to use inverse operations to undo operations and isolate the variable. And let's go ahead and take a look at examples of that. Here in example 1, we have sports application, and taking a look at our helpful hint over here, a number divided by itself equals 1, as long as that number is not equal to 0. So t over t equals 1. Said that a lot in class. Any number over itself is equal to 1. So in 2004, Ernest Van Dyke won the wheelchair race of the Boston Marathon with a time of about 1.3 hours. The race was about 26.2 miles. What was his average speed? Using the formula d equals rt, where d is distance, r is rate, and t is time, and round your answer to the nearest tenth. So the question asks for speed. So first, solve the formula d equals rt for r. Well, right now d is isolated, but we want r to be isolated. We want to solve it for r so that we can then find out what his rate of speed was. So the r is related to the t through multiplication. The opposite operation is division. Remember, every fraction is a division problem. So we're going to divide rt by t so we can get r by itself. And what we do to one side, we do to the other. Those t's are going to cancel each other, leaving us with just r on the left, and we end up with dt over here. Or we could just flip it around, put the r on the left and the d over t on the right, and have r equals dt. Now we can use this formula and the information that was given in the problem. So we know that r equals d over t. Let's go ahead and plug in our distance, 26.2, plug in our time, 1.3, and we get approximately 20.2. So Van Dyke's average speed was 20.2 miles per hour. Also notice that the squiggly lines here, it looks like an equal sign, but they're kind of like squiggly or wavy. This means approximate. It doesn't mean exact, it means approximately. And we would use that because if we look up here in our question here, it says about 1.3 hours, not necessarily exactly 1.3 hours, and the race was about 26.2 miles. So since it was about and not exact, we would then use the concept of using approximation symbols. So this would be approximately as opposed to equal. In example 2, solving formulas for a variable. The formula for a Fahrenheit temperature in degrees of Celsius is Fahrenheit is equal to 9 over 5 times C plus 32. Now they want us to solve for C. In our remember over here, it says dividing by a fraction is the same as multiplying by the reciprocal. So that'll come in handy, multiplying by a reciprocal. So let's start off with the equation for Fahrenheit. Fahrenheit equals 9/5 C plus 32. And we want to isolate the C. Well, before we can get to the C that's here that's tied to the 9/5 using multiplication, we first have to get rid of the addition here of the plus 32. So the opposite operation of addition is subtraction. We're going to subtract the very number we wish to get rid of, which is 32. And what we do to one side, we're going to do to the other. So it's going to cancel the 32s over on the right, but it's going to give us a negative 32 on the left. And we now have F minus 32 equals 9/5 C. Well, remember we want to get C by itself. So C is tied to the 9/5 through multiplication. We could go ahead and divide both sides by, or multiply both sides times 5 and then divide by 9, or we could just take a shortcut and we could just multiply 9/5 times 5/9, because when we multiply by a fraction's reciprocal, then we end up with a value of 1, and 1 times anything times 1 is itself, so it's kind of like it just goes away in a way. So let's multiply 9/5 times its reciprocal. Remember, its reciprocal is just flip the fraction over. So we have 5/9. We're going to what we do to one side here, multiplying the right times 5/9. We're also going to multiply the left times 5/9 as well. Over here, 5/9 times 9/5 is equal to 1. 1 times C equals C, so we end up with just C on the right. Over here, we multiplied 9/5 times the left as well, so we get 5 over, and I said 9/5, 5/9. So we multiply 5/9 times the right as well, and we get 5/9 times the quantity of F minus 32 equals C. Now, the skill of being able to do something like this would come in handy, because right now the F equals, Fahrenheit equals 9/5 C plus 32 is good if in the event that you have the Celsius temperature and you want to find out what Fahrenheit is. You would plug in Celsius and that would give you Fahrenheit. But what if it was the other way around? What if you had Fahrenheit and you wanted to know Celsius? Well, down here you could plug in Fahrenheit and then you would get Celsius. It's kind of like we switch the input and the output of the function, right? The input becomes the output becomes the input. All right, next one. The formula for a person's typing speed is S equals W minus 10E over M, where S is the speed in words per minute, W is the number of words typed, E is the number of errors, and M is the number of minutes typing. They want us to solve for W. So let's locate W. We see W is here in the numerator of the formula. And we also notice that the W minus 10E is being divided by M. So we need to get rid of this fraction first. So in order to get rid of a fraction, you know it, let's multiply by the denominator. So we're going to multiply both sides by the denominator M. We see that here and here. The M's are going to cancel each other, leaving us just with what's in the numerator, W minus 10E. We see that right here. And M times S becomes MS. Next, we want to get the W by itself. Remember, that's the objective here. It's tied to a 10E through subtraction. The opposite operation of subtraction is addition. And we're going to add the very value we wish to get rid of, which is 10E. So we're adding 10E to the right. So we'll do that also to the left. The negative 10E and the positive 10E are going to cancel each other, leaving us with just W on the right. And now we're going to have MS plus 10E, and we see that right here, MS plus 10E. So in the end, we end up with W equals MS plus 10E. A formula is a type of literal equation. So here's our definition of literal equation. A literal equation is an equation with 2 or more variables. So if it has 2 or more variables, then it is a literal equation. To solve for one of the variables, use inverse operations. So here we have example A, solve M minus N equals 5, and they want us to solve for M. First of all, is this a literal equation? Indeed it is. It has 2 variables, M and N. So let's go ahead and locate the M here. The M's located here. It's having N subtracted from it. So the opposite operation of subtraction is addition. We want to add the very number we wish to get rid of, or value, or variable in this case. So we want to get rid of this n, so we're going to add n. What we do to one side, we're going to do to the other. The negative n, the positive n, cancel each other, leaving us with just m on the left. And now we have 5 plus n, which is what we see here. So the solution is m equals 5 plus n. On the next one, solve m over k equals x, and they want us to solve for k. So let's locate k in the equation. We see that it is in the denominator. And whenever we want to get rid of a fraction, what do? We're going to multiply by the denominator. What we do to one side, we're going to do to the other. So we multiply both sides by k. The k's cancel each other, leaving us with just m. And we now have kx on the right, so m equals kx. But we need to solve for k, so we're not quite there yet. So now the k is tied to the x through multiplication. The opposite operation is division. Remember, every fraction is a division problem. So we're going to divide by the variable or value we wish to get rid of. And so we're going to divide by x because we want to get the k by itself. What we do to one side, we're going to do to the other. The x's are going to cancel each other, leaving us with just k on the right. And we now have m over x on the left, so k equals m over x. So we've taken m over k equals x, and we solved for k, and got that k is equal to m over x. On this one here, I think is, let's see, they just m over x. Yeah, they just switch positions. If you get a lot of these where it's something over something equals something, and they want you to switch, they want you to solve for whatever that denominator is, and just a simple one like this. For instance, let's do another example. If I had a over b equals c, and they say solve for b, then I know that b is going to equal a over c. They just switch places, right? And if I did the work for that one, let's see, let's grab that. Let's grab this here. Can I grab, oh, no, don't want to grab that. Never mind. Let's go ahead and do it that way. Can I get all this? No, I can't. Doggone it. Okay. Let's see. Let's go ahead and see if I prove myself correct. Go through the steps. So we want to solve for b, right? We want to get b by itself. So we would multiply both sides times b. And whenever we do, the b's would cancel, leaving us with just a on the left, and we would have c times b. Now we need to divide by b, or no, divide by c, correct? We're going to divide by c to get it by itself. What we do to one side, we have to do to the other. The c's will cancel each other. We end up with b and a over c. So notice that in this, they just switch places. So a little bit of a shortcut there. You do enough of those and you're like, oh, they're just going to, the denominator and the isolated variable are just going to switch places. So, all right, guided practice. Looking at this one, vocabulary, explain why a formula is a type of literal equation. Well, we know that literal equations have two or more variables, and formulas always have two or more variables. So they both have two or more variables. So since a formula has two or more variables, it will always fall into the category of a literal equation. Construction. The formula A equals 46C gives the floor area A in square meters that can be wired using a number of C circuits. Solve A equals 46C for C. So let's go ahead and do that. So I have A equals 46C, and they want me to solve for C. So let's divide both sides by 46, not 44, 46. And the 46s will cancel each other, so I end up with C equals A over 46. Now, if a room is 322 square meters, how many circuits are required for the area in this room? So that's the area, right? Right there. So I just need to do C equals, and 322 over 46, and therefore C would equal, and I'm going to use my calculator for that one, 322 divided by 46. Number of circuits would be 7. All right. Let's look at, let's just jump down here to the bottom. Let's do just picking 4 and 7. We'll try those. So we have st plus 3. Oh, that was weird. What happened? I think it did a save in between. 3t equals 6. And they want us to solve for s. So here's what we need to solve for right there. So notice that first we need to get rid of the 3t over here. So we're going to do st, and by subtracting 3 from each side, we'll move it to the other side, end up with 3t. Now I need to get the s by itself, so I need to divide by t. And therefore, the t's are going to cancel each other, leaving me s on the left. And I have 6 minus 3t, 6 minus 3t over t on the right. There's 2 t's in there? Yeah, there are 2 t's. And no, I can't cancel those. See the subtraction there? Don't try to do some kind of weird canceling thing either. That would be the final answer. All right, on the next one, I have b plus c equals 10 over a. They want me to solve for a. So a's in the denominator. What are we going to do? We're going to go ahead and multiply by the denominator, right? Put all this here. Do a. The a's will cancel each other, leaving me with 10. And a times b plus c. And now I want to go ahead and get a by itself, so I need to divide by the quantity of b plus c. What I do to one side, I'm going to do to the other. And the b plus c's will cancel each other, leaving me with a on the left. And I end up with 10 over b plus c. And indeed, they want us to solve for a. Notice that they just switched. I could have used that shortcut there. Let me go back to the shortcut there. Let me erase all this here. We have our answer over here. Remember that shortcut I told you? I know it doesn't look as obvious this time. B plus C equals 10 over A. They want us to solve for what the denominator is, right? That's what I had on that last one. Here they say, they said solve for K. And the K and the X just switch places. They want us to solve for what the denominator was. So they just switch places. Well, if we look at this here, if we just take the A and the B plus C and switch places, right? Take our equal sign, and we're going to put our 10 here. And now the A is going to go over here, and the B plus C is going to go over here. And these two are indeed the same. We went through the work to show this one is correct. And then we took the shortcut here, and we get the same thing. All right? So that is the completion of my presentation for Chapter 2, Lesson 5 of the Algebra 1 textbook, Solving for a Variable. Thank you.